Hello, everyone, and welcome to the webinar, Tackling Infiltration and Inflow with SLiiCER. This is a part two of a multi-part webinar series. Today we'll be focusing on understanding dry weather flows. My name is Eric Lott. I'm the marketing manager here at ADS, and I'm going to be serving as your host today. Today's presenter is Kevin Infinger. Kevin is a senior product and region engineer at ADS Environmental Services with 30 years of experience in environmental engineering and consulting. He holds a Bachelor of Science in Chemical Engineering from the University of Florida and is a registered professional engineer. Kevin's a member of the American Society of Civil Engineers and the Water Environment Federation. So Kevin, without any further introduction, I'm going to turn it over to you and thank you for all you've done to prepare this webinar.
Thank you, Eric. So thanks everyone for joining us today. Just looking at the list, it looks like we have some old friends and some new friends joining us today. So I'm happy to have all of you here with us today. So a little bit about this webinar series itself first. I think it's fairly obvious to most people in the wastewater profession that most sewer systems out there have an infiltration and an inflow problem, or an I&I problem. So if you do, you're certainly not alone. And resolving that problem or working through that problem often starts with flow monitor and rainfall monitor data as part of an I&I study. So the purpose of this particular webinar series is for us to learn how to apply SLiiCER, which is our cloud-based I&I analytics tool, to understand and prioritize I&I in your wastewater collection system. So about a month ago, we had our first webinar in this series. The part one, I called it the big picture. I gave an overview of SLiiCER itself and really talked through it at a high level. And what we're going to do today in part two is take a piece of SLiiCER, that part dealing with understanding dry weather flows, and we're going to dive a little deeper into that topic and into those features. We're going to come back with a part three series called Understanding Wet Weather Flows, where we'll touch on that piece. And I think based on the questions I get from these first three parts, I think there's going to be some other sections we may want to focus in on and dive into a little further. So I do envision more past part three, and we will continue this when we have other sections we want to focus on and people have questions about. So what is SLiiCER itself? So SLiiCER is our I&I analytics app from ADS, and it's available through Prism, which is our cloud-hosted web app. And the simple way to put it is SLiiCER puts some powerful tools at your disposal that allow you to get a grasp and get a handle on I&I in your system. So some of you may have worked with Prism already from ADS. If you worked on, or if we have worked on flow monitoring projects with you, you're probably already familiar with Prism. It's our cloud-based data platform. So this diagram gives you a good feel for what's happening in that process. We get data from flow monitors and from rain gauges. That data is sent wirelessly to the cloud. And a lot of people, at least at first glance, probably think of Prism just as a data warehouse and a data viewing tool. But there's other features in that Prism data set, including SLiiCER, that provide additional analytics. And SLiiCER is that I&I, or infiltration and inflow analytics piece within Prism. I presented this graphic in the part one webinar, but I thought it was worth showing again because it's a good reminder conceptually of what SLiiCER is doing. So there's actually a lot on this particular graphic, and I just want to walk through it quickly here. So when it comes to an I&I study, there's really two data streams we're looking at. One is a set of rainfall data, and the other is a set of flow data. And we may have multiple rain gauges, we may have multiple flow monitors, but I'm showing conceptually what's happening for one of those. So we have rainfall on the top here, and of course, when it rains, you can see what happens in the sewer system below. There's a response in the system every time it rains, and that response is dependent upon the type and the amount of rain that we receive. So before we can understand I&I and what's happening in wet weather, we first have to understand dry weather. We're going to focus on that piece quite a bit today. So you'll notice I've got some days just kind of marked off in green on this hydrograph in the middle. And those are just conceptually representing what's happening in dry weather or normal flow conditions. Now, if you take a look at that bottom left graph, I call that a dry day hydrograph or a dry day composite hydrograph. And we're taking all those days that are marked in green on the hydrograph above, and instead of plotting them end to end, we're plotting them one on top of the other from midnight to midnight. And it reveals these dry day diurnal patterns that we see, in this case, on weekdays and weekends. We get a lot of information out of just that part of SLiiCER. So think about the minimum, the average, the maximum dry day flows, but we can also get estimates on what we call wastewater production and base or groundwater infiltration in your system. Once we have that dry day information, we're able to look at individual storm events, and we can then calculate the I&I from each of those individual events. On this third graph on the bottom, we can then start to relate how much I&I you get for how much rain, and we look for a consistency in that. So I have 8 rainfall events on this slide, and you'll notice 8 data points representing the I&I from those different events. Ultimately, we want to take the results from this particular flow monitor or this particular flow monitor basin and compare it to other parts of your system. And we will stack rank those in terms of I&I severity. So I think it's almost universal throughout the wastewater collection systems we work with is most of those utilities, most of those systems do not have the funds to address all of their I&I all at one time. So there's always a need to prioritize, and this is one of the good ways to make that prioritization happen. That's conceptually what SLiiCER does. I think each time I do one of these webinars, I will come back to this slide and then we'll dig in further. So the piece that we're going to talk about today is this little graph over here and what's entailed in that. So really at a high level, the goal of SLiiCER is to break the data up, or to slice the data up, if you will, into dry weather and wet weather components. So today we're going to focus exclusively on the dry weather piece. Come back and join us for part 3, and we will focus exclusively on the wet weather piece. Now, you'll find inside SLiiCER, we operate under the concept of a SLiiCER study. So a SLiiCER study is just a collection of flow monitors, a collection of rain gauges for a specified time period. And we refer to that in SLiiCER as a study. And once you create a study in SLiiCER, that study is then managed under 6 tabs. So there's a configuration tab, there's a settings tab, there's a basins tab, rainfall, flow, and results. And in terms of dry weather features and functionality and insight, we're going to focus on these 4 tabs that are shown here. And that's where the functionality related to dry weather features is located. So you'll find that under settings and basins, and you'll find that under the flow tab and the results tab. We're going to walk through each of these. I'm going to do some of this in slide format, and then I'm going to switch over and show you a live demo on our production system. So let's start with the settings. And I think when you see some of the settings, you'll understand some of the fundamental ways that we're evaluating this data inside SLiiCER. So here's an example of one of our settings pages. You'll notice I've got those 6 tabs across the gray bar at the top. You'll notice configuration, settings is highlighted here, basins, rainfall, flow, and results. That's your basic navigation inside a SLiiCER study. So we're sitting here in settings, and there are some sub-tabs along the left, and I'm on the dry day sub-tab. And the settings, think of these as the definitions of what SLiiCER is using for its default calculation algorithms. So when you create a study, before you ever get into the study, SLiiCER has done its first cut of calculations for you, and it's based on these settings. So one of the first things we have to do is we have to define what a dry day is. And that may sound a little silly at first glance. It's kind of like defining a rain event. We know what a rain event is, right? Intuitively we do, but we have to put some numbers behind it so that an algorithm can operate on that. So if you've seen like an I&I report written by me in the past, you'll often see a statement like this in the report. It's dry day flow conditions are characterized by evaluating sewer flow monitor data observed during normal conditions. And what are normal conditions? Well, those are days when it's not raining, and they're days when the system is not recovering from a previous rain. And so to get that, we have some definitions, and I'll walk through these on another slide here when you can see the actual numbers. But you can see we've got 1, 2, 3, 4, 5 parameters that are set in SLiiCER to help automatically identify what a dry day is. Now, the numbers that we use in these default settings, they are what I would call ADS defaults. They're things that over the years we have found that work in general and work pretty well in most cases. But we also find that people in different parts of the world, different climates, different systems may have some different numbers that suit them better for the purpose at hand for them. And for that purpose, these settings can be changed. They can be changed on an individual study level, or they can be changed globally for a particular customer, so that every time you create a study, you're using your own criteria for these particular terms. So what do these terms look like? So I'm going to show you the results, or what these settings look like for what I call a US customary units of measure customer and for a metric customer. So let's take the US customary units first. The dry day selection process for us in our automated algorithm is a two-step process. The first step deals with rainfall. So in step 1, you'll notice that we're going to throw out any day on which it rained, and we're going to throw out any day on which it exceeds certain rainfall amounts. So we look at not just, let's say we sweep through all the days in a study. Let's say we're looking at day 5. Well, if it rained on day 5, we're going to throw that day out. But also, if it rained a certain amount on the previous day, day 4, we're going to throw day 5 out as a dry day. If it rained a certain amount on the previous 3 days, or if it rained a certain amount on the previous 5 days, we're going to throw day 5 out. So that's a way of eliminating days on which it rained, and it's a good day of limiting days on which you're likely to be recovering from a previous rainfall event. So after that process is done, we come back and we take all of those days that are left and we average them together. And we average them into a diurnal curve for each day of the week group. And think of that as like weekdays and weekends. Step 2 is to come back and then look at the flow rates. And I like to think of these settings here as what I call a bandpass filter. So you take off the days that are too high above the average and too low below the average, and then you leave everything else. So these are the default values we use for our US customary units customers. So people that are accustomed to thinking of rainfall in inches, these are the numbers. If you're a metric customer, say one of our customers in Canada or elsewhere, these are the settings that we use by default. And again, these settings are adjustable. So for example, here we're going to throw out any day on which it rained. The previous day, we're looking for rainfall less than 2.5 millimeter, previous 3 less than 10 millimeter, and the previous 5 less than 25 millimeters. Again, these parameters are adjustable, but that's to get you started. The other setting that we have that's available that's related to dry weather flows is the setting to estimate what the base infiltration method is. I'm not going to get into the details of these methods today. I've got another paper and another webinar that you can reference on the technical details, but I just want to show you that you have options. So you'll see the term base infiltration used inside of SLiiCER, and it is synonymous with the term groundwater infiltration. So if you see these two terms, base infiltration or the abbreviation BI, or if you see groundwater infiltration or the abbreviation GWI, just know that those are synonymous in this application. So we do have three different methods that are currently available to estimate base infiltration from the dry weather flow data. And one of them is called the percent minimum method. One is called the wastewater production method, and the third is called the Stevens-Schutzbach method. Just a note, we do have a fourth method called the Mitchell method that is scheduled for release soon. My guess is it'll be out before the end of the year. You'll notice some of these methods also have some values that you can adjust. Like, for example, the percent minimum method, basically it takes and says your groundwater infiltration is a certain percentage of your minimum dry day flow, and you can set that value. Again, we start out with ADS defaults that we find that work pretty well in general, but you have the flexibility to adjust those as well. Now, another setting related to dry day flows is the day of week groups. And by default, we use weekday and weekend groups. And you'll find that that works best for, I'll say 95 to 99% of the work you'll do in I&I studies. But I want to show you that you do have the flexibility to change that. I can go with as few as one day of the week group. In other words, I'm going to lump all 7 into one, or I can use as many as 7. I can have one day group for each day of the week. I think in practice, the most I have ever used has been 4. And those are nice to have when you need them. So that takes us through some of the settings related to dry day flows. I want to talk about the next tab that's affected is the Basins tab. Now, the Basins tab is, I like to refer to it as where the metadata associated with an I&I study resides. So you primarily think of the main data input for an I&I study being flow monitor and rain gauge data, and that is true, but you get the most out of an I&I study when you couple that data with other data related to the basins from which the data is gathered. So there is, you'll notice on this particular page, here's the Basins tab, and again, I have some sub-tabs here, one of which is called Properties. And these are the properties of the basins associated with each flow monitor. And the properties that we have that we can store relative to dry days are the acres, the sewer length, and the footprint. So the sewer length, footprint are basin properties. They're not required actually to run SLiiCER, but they do help provide some additional insight by putting calculations from SLiiCER into context. And so the area is the land area of the sewer basin. In US units, that's going to be in acres. In metric units, that's going to be in hectares. The sewer length is the amount or the length of sewer pipe contained within that basin. And the footprint is think of it as the profile area of the sewer. It's expressed in what at first glance is a funny unit of measure. Is called inch miles or millimeter kilometers in metric. So again, those are provided in US customary or metric units. We can handle either one, and it just depends on how your study is set up and what units as to which units you'll be using. So the other thing to remember about this information is this is not data that comes from your flow data or your rain gauge data. This is data that's often obtained through your GIS information. So for us at ADS, if we're doing this type of analysis for a customer, we will either go directly to the utility or the owner of that wastewater system for this information, or we are obtaining it through a consulting engineer. But somebody with access to GIS information is where this information comes from. Now, let's take a look at the other two areas. I'll talk about some things related to the flow tab, and then I'll get into a live demo. So I'm showing you just conceptually a hydrograph of flow rate data here. So this happens to be from a flow monitor in Southern California, and it happened in a period of time where they did not get any rainfall. So you can see this pattern is very consistent. So this is what we call a repeatable daily or a diurnal pattern. And you'll notice I've got weekdays and weekends marked on this graph as well. So the weekdays are in green, the Saturdays and Sundays, the weekends are shown in blue. Now, instead of plotting those end to end, if I plot them one on top of the other, I start to see these dry day patterns emerged with a lot more clarity. And this is actually the first observation that we see with these dry weather flows is that there is a difference between weekday and weekend flows. Now, this is starting into a study of what I call sewer sociology. So if you've seen some of those articles published by ADS over the years, this is how we do that type of analysis. And the interesting piece of trivia about sewer sociology is it actually started as a byproduct of our work with SLiiCER. So we were evaluating these dry day flows as part of I&I studies, and we started noticing all these differences between different days of the week, between holidays and regular days, and then other things that would happen that would seem to be unique and different from dry weather and wet weather flow. But that's how we started our path down sewer sociology, is understanding these day of week group differences. So you can see that you quickly see the difference between weekday and weekend here when you're plotting these days on top of each other midnight to midnight. One of the other things you'll start to notice as you start to use SLiiCER is even within these dry day patterns, you will start to see differences. And I'm showing you 6 different patterns here. And the only thing that's really different about them is the land use characteristics of the basin that they're originating from. So when most people in the wastewater industry, if you ask them, can you draw me the diurnal pattern of what sewer flows should be? Most people, without any other information, they will draw you this pattern on the top left, which is representative of the typical residential pattern. But you can see we see all other kinds of patterns as well. There's a central business district that's here in the top center. There's an office park here on the top right. Bottom left is a hotel. I've got a theme park here in the bottom middle, and even a meat packing plant that happened to be outside of the Nashville, Tennessee area on the bottom right. But land use definitely affects the shape of these diurnal patterns, and you want to be able to understand what these patterns look like before you can do the wet weather analysis later on. Now, once we have these dry day curves, we can readily extract some useful statistics from them. The easiest thing to pull off is the basic statistics, and that is what I call the minimum and the average and the maximum dry weather flow rates. Now, with these minimums and maximums, these are not the minimum and maximum of all of the days. It's the minimum and maximum of this average curve. So this bright green curve right here, it's what is the minimum flow on that curve, which is going to be down here in the early morning hours. What's the maximum, which in this case is going to be in the morning, and then of course the average is sometimes in the middle. You'll see this maximum sometimes at different places in the day, and again, that's often indicative of the land use of the area. From this information, I can take this maximum, divide it by that average, and get a dry day peaking factor, which we also provide. So these dry day curves and these dry day characteristics are calculated for every day of the week group that you have. So by default, that information is going to be generated for weekdays and weekends. Now, the other thing that we can do with these dry day curves is split them up into estimates of two key components. One we call the wastewater production, and other people may refer to this as base sanitary flow. Think of this as everything that goes down a toilet, down a kitchen sink, dishwasher, washing machine, any of that is discharged into a sewer. We refer to that as wastewater production. The other water that gets in a sewer in dry weather is what we refer to as the base infiltration or the groundwater infiltration. So in SLiiCER, we're using the base infiltration method that's been selected to estimate what this base amount is, and then the difference is classified as the wastewater production. So that's how those estimates are done. These values are not measured directly by flow monitors, but they're estimated based on the characteristics of the data that we see out of these dry day curves. Now, at the end of the day, it's important to put this type of data into context. And so there are a few different what I call KPIs or key performance indicators that can be used. And you may pick and choose several of these to use, or you may use none of them. But depending on what you're doing, I think some of these KPIs will be relevant and useful. One is to normalize the wastewater production estimate by the basin sewer length. And this is a KPI that was developed by a colleague of ours, Patrick Stevens. And so this is a rule of thumb from him. And he always said you look for 2 gallons per day per linear foot of sewer. And that was typical wastewater production number you would expect from a low density single family housing area. So think of a typical subdivision. And then here's some other numbers from Mr. Stevens on some other densities. And you can see this is reflective of land use in the area. And you ask the question when you're looking at your results, does the wastewater production number that I'm seeing, does it make sense with what I know about this basin? That's one way to take a look at that. The others deal with the base infiltration or the groundwater infiltration. And often, if you're trying to compare these with sewer design guidance or local design expectations for groundwater infiltration, you will normalize these results either by acre or by sewer footprint. And so I've collected the sewer design guidelines from a number of communities around the United States and Canada. And these are just some examples I kind of plucked out of that library of design standards I have. And you'll see there's quite a bit of variation. So what's considered excessive I&I in one system may not be excessive in another. And the idea here is you want to take your results out of SLiiCER and what is your base infiltration or groundwater infiltration estimate, and you want to compare it to your local design standard. That can be a helpful metric. And then another colleague of mine, his name's Paul Mitchell. Sometimes we're not necessarily privy to all the GIS information we would like to on a study, or we may not have time to gather that information if we're doing a quick and dirty study. And so Paul developed a rule of thumb or an approach of just comparing that base infiltration estimate to the average dry day flow. And in this particular approach, if you're under 20%, he says that's reasonable. If you're above 40%, then you've got a significant problem in terms of groundwater infiltration in that basin. So these are several key performance indicators, or KPIs, that let you take that calculation of either your wastewater production or your groundwater infiltration and put it into perspective and ask the question, does it make sense, or is it indicating that there's a problem or not that we need to pursue further? All right, now I'm going to take you inside SLiiCER and show you a live demo of some of these features and actually walk you through some of the other interactive control that you as a user have to get to these dry weather numbers and to review those results. So inside Prism, on the home screen for any given customer, you have a black toolbar, and on that black toolbar is an option for analytics, and if you select that option, you can get to SLiiCER if you have permission to use it. So I'm going to go into SLiiCER now, into Prism, into the live application, and we're going to take a look. So I'm going to sign in here. And here we are. So you'll notice I'm on a home screen. I'm here in a customer called Customer SLiiCER Demo. I'm going to go to Analytics, and I'm going to select SLiiCER. And that takes me to something called a SLiiCER dashboard. Now, I've already explained the concept of a SLiiCER study. It's just a collection of flow monitors, a collection of rain gauges for a specified time period. Now, the SLiiCER dashboard allows me the means to manage one study or many studies. So I don't have to have any studies here, and I can have as many as I like. So I can archive them here. I can keep them as long as I like. When I'm done with them, I can delete them. So I'm showing you here on this dashboard two different studies that are here, and I'm going to select the one in the first row here. I'm just going to click on that row, and that will take me into the study. So here you see those 6 tabs I mentioned earlier. That's really the navigation through any SLiiCER study. I've got a configuration, got settings, basins, rainfall, flow, and results. And so let's go to this settings tab. I illustrated some of those features earlier. Right here on this first sub tab is the dry day settings. So this is the maximum rainfall on the previous 1 day, the maximum previous rainfall on the previous 3 days, and the maximum previous rainfall on the previous 5 days. I've also got my bandpass filters here at 85% and 115%. So that is the definition of a dry day in SLiiCER. These are our default parameters. If I want to change any of these, I just click in here, I make that change, and I apply that change, and it will be saved to this study. We have another place in Prism where if you want to make this a global change for you as a customer, you can make that change elsewhere. But this one is affecting only this study. The next option I have is to set the base infiltration method. Here by default, it's set to what we call the Stevens-Schutzbach method. And I can just hit this drop-down list and change that to another method if I prefer another method and apply that change. The day of the week group setting, it's right here. And you can see by default, it is set to weekdays and weekends. If I want to change that, I can simply add another group down here at the bottom. That will add another row. And then I can make these adjustments to the days that are assigned to each group. The only rule here is that every day has to be assigned to one day of the week group, and you cannot assign 1 day of the week, like a Monday, to more than one group. So those are the only rules that dictate this process here. If I need to change those, I need to delete a group, I can do that as well. Once you make changes like this, SLiiCER will automatically recalculate anything it needs to for the study. So those are the settings related to dry weather flow calculations. The basin tab, the first thing you'll see is the network subtab. We're not going to talk about that today. I'm going to go down here to properties. And here you can see those three basin size parameters. So one is the area right here that's currently blank. I've got some numbers here entered for the sewer length. And then I have the area where I can enter the sewer footprint as well. So those are the parameters that most people will use when they're trying to put that dry day perspective, the data into perspective, or to normalize that data, if you will. Now we're going to skip the rainfall tab today because that doesn't affect dry weather, but I'm going to go to the flow tab now. And I think most people that see SLiiCER or that use SLiiCER, this is probably the most interactive of the different tabs that are in here. And probably as a SLiiCER user, you'll spend more of your time here than you will in other places in the app. So there's a number of things that are showing on this window at one time. The first thing that's here is what I call the main hydrograph. And it is simply the flow rate data and the rainfall data associated with this particular basin on the list here. And it is for the entire duration of the study. So this particular example study starts on January 1st of 24, and it runs through the end of April 24. So it's 4 months worth of data that you're seeing here. Of course, I can zoom in, zoom out, pan left, pan right, do all that stuff that you would do on any interactive graph in an application like this. I can also turn off some of this information. So I'm going to turn off Show Storms. And what you're seeing is just the dry weather related information here. So the first thing that you're seeing on this graphic here is you see some of these days are shaded green and some of these are shaded blue. And that's to represent weekdays and weekends that are considered by SLiiCER currently to be dry days. Now I can't guarantee that these are all the default algorithm days because I've played around with this particular data set some. But let's scroll down to the bottom, and you'll notice on the bottom left here I have the dry day subtab, and it's showing me a dry day hydrograph, midnight to midnight. And all of the green days on this graph are the same green days that are shown in the graph above. So it's telling me the overall pattern on the bottom left, and it's showing me all of those days, and up at the graph on the top, I can see which days those were. Now, if I want to change any of this, I can certainly do this. So I can select Edit Dry Days, and let's turn off that weekend for now. And if I want to get rid of this day as an outlier, and maybe I want to take out a few of these other days, I can simply do that. You'll notice the days are highlighted on the graph at the top. So I know where they came from, and I can see how they stack up relative to these other days. And if I want to remove these, I can simply remove them. If I want to take out a few more, I can do that. And you can get as, I'll just put it this way, you can get as picky as you like with this. And I find if I'm doing a quick and dirty I&I analysis, I will typically run with these defaults because they're going to get you to the right place. If I need to be more particular or more discerning, I may take a closer look at these, and I may choose to be a little more picky about what I select or what I don't select. But once I revise these, I simply hit apply. All those changes are done at once. And you can see how fast that went. So once I hit apply, SLiiCER updates this graphic at the top, showing the days that have been selected. It recalculates and displays the information here in the graph on the bottom, and the statistics associated with these are updated in this dry day statistics table as well. Let's take a look at this dry day weekend curve. I can do the same thing here, and you'll notice, see, I had been playing around with this earlier, and it's got some days that have some rainfall in them. And it just shows you how obvious that looks on a graph like this. I'm going to take these back out, and we're going to remove those and hit apply. Let's get this back to normal again. Take that day out, that one. And there we go. So one of the ways I like to explain this to people is SLiiCER has some default algorithms that will do a lot of the heavy lifting for you, take an initial cut at it. But one of the things I've learned over the years is engineers don't necessarily like black boxes. They can be handy, they can run some calculations fast, but if you don't understand what they're doing or you don't agree with what they're doing, that's a problem. So one of the things that I like about SLiiCER is it'll take that first cut, and then I can come in as a user, as an engineer, I can come in and use my own judgment and say, well, I'd also like to take these other 2 days out and update the calculations. So you get to insert your own professional judgment, and then let SLiiCER update the calculations and do the heavy lifting on the calculations. So that's a quick and easy way to review dry day curves and to update that information. If I wanted to push this to its extreme, I could come in here and take every day off, start with 0 dry days, and build this back up from scratch. Or I could do the opposite. I could turn every single day on as a dry day, just override SLiiCER's algorithm, and then start taking things away to get to that answer. So it's completely flexible in that regard and how you'd like to do that. Let's look at some of these statistics that you get out of this dry day information. You'll notice I have a column for each day of the week group. So I've got one for weekdays and I've got one for weekends. I'm showing you the number of dry days that are contributing to these curves. So there's 40 weekdays selected, and there's currently 16 weekend days selected. You'll see the minimum flow, the average flow, and the maximum flow here, as well as the peaking factor. Then you'll also see the estimate or the split between wastewater production and base infiltration. Now, the other thing you'll see on SLiiCER, I haven't touched on it in this webinar so far, but we did talk about it in the last webinar, is the concept of gross versus net calculations. So anytime you see gross in SLiiCER, it's referring to the total flow coming through the monitor. So those statistics are based on that total flow. If you see net, it is the total flow from the monitor or from that basin minus any flows from any upstream basins that are also monitored. So when we talk about basin properties in terms of area, in terms of sewer length, in terms of footprint, those are always associated with the net basin. So you want to exclude the areas associated with anything that's monitored by an upstream flow monitor. SLiiCER does that math for us automatically. So it's going to give us the gross flow. So if you were, for instance, looking at flow capacity through this pipe, you want that total flow that's coming through the pipe. But if you're looking at I&I numbers and trying to prioritize the basins, you're going to want to look at these net numbers down here. So that's how SLiiCER operates. It does that automatically for you. Now, the other thing I want to show you is the results. So again, this particular window, this flow tab in SLiiCER, basically deals with the individual basins. So you can see how I can navigate through those, and I can get the detailed information on each one of these. Now, ultimately, though, I'm going to want to get some summary statistics, even compare results across basins. And I do that in the Results tab. So that's the last tab here. And you'll notice again, I have a number of sub-tabs on the left, and I have dry day statistics. And I can actually put this in a grid view instead if I would like to see the numbers here in a tabular view, or I can look at them graphically. But basically every number we're calculating in that dry day statistics table is shown for you here across the different basins. So you're seeing it all together. So I can take this information, I can graphic, I can export it, I can get to that information pretty easily. The other information that we have, and I find that the modelers are often interested in this, is we give you the data associated with the dry day hydrographs. So those dry day curves, you'll notice I've got here flow monitor 01, the day group is weekday, and I've got hour 0, 1, 2, 3, all the way up through 23, and then you repeat those numbers again. So this data for the weekday and the weekend curve for every flow monitor in this study is provided in this table, and you can get this information out as well. So that's some of the information you can get to and how you can access it. And let me go back to my PowerPoint here. And let's talk about a few key points to remember. We're going to wrap things up here. So just remember that SLiiCER is a suite of I&I analytics tools, and that we use that to extract insights about I&I from sewer flow monitor and rainfall monitor data. And in terms of the dry weather, we can distill that dry weather information. We can slice it out of the data, if you will, to support I&I analysis or other analyses. So if you're doing some capacity analysis work, you might be looking at dry weather flows. You can get that out of SLiiCER. And then I mentioned this other one, but I want to mention it again here. In terms of how SLiiCER operates, SLiiCER is meant to work with you in doing an I&I analysis. So it's not going to do everything for you. It'll give you a good cut at what those calculations are. But it also gives you the displays and the views to see what's happening at each step along the way, and allows you to make adjustments to that that you would deem necessary. So it does the heavy lifting on the calculations, but it leaves you in control of what is being calculated. And then if you'd like to take a closer look, you'd like to get your hands on this yourself, let us know, and we can reach out to you and let you get access to SLiiCER with a demo yourself. I do want to touch on some of the technical topics that we talked about today. A lot of what I showed you earlier was what I call the how-to of how to use SLiiCER. So it's how to navigate through it, what it's doing, and what it's displaying for you. If you want to understand some more of the technical aspects of what SLiiCER is doing, what I call the why-to, I've got some other information. So one is a technical paper. It's referenced on top here. It talks about these different groundwater estimation methods. So if you'd like to know a little bit more about each method, what it is, how they compare, kind of what their strengths and weaknesses are, and when they should or shouldn't be applied, that information is available in that particular technical paper. You can get to that one on our website at the link shown here. We have also done in the past a webinar focusing on the technical aspects of what you can extract from this dry day data. So it's a webinar Paul Mitchell and I did a few years ago. It's available in our webinar archive. So if you'd like access to that, there's the link for that. And speaking of other webinars, I also wanted to make sure that you know there is a previous 7-part webinar series about I&I measurement and methods. Again, it focuses more on the technical aspects of I&I work, and also gives some good insight and wisdom that we have picked up as a company over the years in doing this type of monitoring work and I&I work as well. If you want to learn more about SLiiCER specifically, again, you can go to our website. There's a web page just for SLiiCER. There's some information that's out there, including some videos and some instructional videos as well, and you can take a look at those. And then our next webinar, our part 3 webinar, Understanding Wet Weather Flows, we're going to hold that in the month of November. So October is pretty busy for us with WEFTEC, but we'll come back the following month and revisit part 3. And with that, Eric, I think we'll take some questions.
Yeah, thank you, Kevin, for the great information today. We really appreciate it. We've had a ton of questions that were submitted on today's webinar, so thank you for that. We had a bunch of questions that were submitted during your registration that were emailed to me, so we're only going to address a handful of questions that were pre-submitted. If we don't answer your question on the webinar today, I promise we'll follow up very promptly and give you a personal answer to your questions. So, Kevin, the first question we have today is, what are the benefits of SLiiCER over the EPA SOAP toolbox?
Okay, so there's actually several differences between SLiiCER and SOAP. I'll go through a few of them. The most obvious is cost. So SOAP is free. It's a piece of freeware sponsored by the EPA, and SLiiCER is not. So along those lines, SOAP was last updated. I think it was version 2.0 about 10 years ago. So I don't know if any future updates are planned. If anybody knows about that, if any updates are planned, please let me know. I'd be interested to know that. But SLiiCER was last updated just this past month, and it's a fully supported product going forward. So we have a whole host of future enhancements we have in mind. We're interested in hearing as people get familiar with it, see what requests they have. And we look forward in continuing to build this product going forward. Another key difference is around RTK. So SLiiCER does not use RTK, SOAP does. We are exploring whether or not we will add RTK in the future. So if you are an RTK or a person interested in RTK, as a product manager, I'm certainly interested in talking with you about some details of that if you're interested in talking about that. When I talk to people that have used SOAP, and I've played around with it myself in the past, most people have tried it simply because it's free. But I also find that most people, they have some user experience frustrations with it. So one of the things in SLiiCER we've tried to do is to overcome some of that. You'll see that the SLiiCER is pretty easy to access. It's tied to the data that's directly in Prism. And then there's some other feature differences. So SLiiCER has a robust rain gauge distribution feature we'll talk about in the next webinar. SLiiCER has 3 different groundwater infiltration estimation methods compared to 1 that's in SOAP. And probably another key feature difference is SLiiCER supports both gross and net calculations, and I touched on that earlier. And that's another distinguishing point there. So those are just some examples of some of the differences between SLiiCER and SOAP.
Kevin, is SLiiCER available to consulting engineers?
That's a very simple answer. The answer is yes.
Okay, which is more problematic, infiltration or inflow?
Yeah, so this was an interesting question. I saw it submitted by one of our registrants, and it's a little bit more of a philosophical question, but I thought it was a good one to tackle. And I'm going to say that the answer is really that it depends. So I think our natural inclination is to say that inflow is always the worst problem. Because we see it hit our systems hard in wet weather. It can overwhelm our system capacity, cause those wet weather sewer overflows, and a lot of times it's the ones that get people's attention most. However, the dry weather or the base or groundwater infiltration is not to be underestimated either. I know this was put in perspective for me years ago when I was working on an I&I study for a coastal community. And I noticed that they were a little bit more keen on understanding what this dry weather infiltration was and how it compared in their system. And so I started asking them a few questions about it, and they said, look, Kevin, we have some of our basins, the flow from that basin gets pumped 4 or maybe 5 times before it gets to the wastewater treatment plant because they're in a flat coastal area. And they said because of that, we're very sensitive to it because it affects the wear and tear on our pumps, and it affects our utility or electricity consumption. So they were very keen on looking at that. But systems with bad base infiltration or high levels of that, it can take away capacity that could be otherwise used for development, residential or commercial. It can take away capacity that could otherwise be used in wet weather. So it can create problems, and it's there 365 days a year. So I'm going to say the answer is which is more problematic is it depends.
Tell you what, Kevin, to get everybody out on time, let's make that our last question. Of course, we'd love to continue to collaborate and talk to you about I&I and certainly SLiiCER. So if you have a question, please send us an email. My email address is on the screen right now. We promptly will answer all of your questions that you submit, and looking forward to talking to you about I&I and SLiiCER. So that's it for today. We're going to wrap it up. Stay safe with the wet weather that's happening out there right now, and look forward to talking to you again soon. Thank you.